Lesson 59, simplifying radical expression. A radical expression is simply a problem without equal sign, and it contains a radical. So it contains a radical, also known as that square root. Rationalizing the denominator I'm going to come back to shortly. What we're going to work with is simplification of this radical. And inside the square root is our radicand, and that's what we need to get into simplest form. In order to get it in simplest form, these little rules here would help you out. Examples that you would run into. If you look at the first example up here, actually right here, we have the square root of AB. That's saying the same as the square root of A times the square root of B. Numerically, if you look at it, you have 4 times 9 would give you 36. We know the square root of 36 is 6. So since the square root of 4 times 9, well, the square root of 4 right here is going to give you 2. The square root of 9 is going to give you 3. When multiplied together, it would give us 6. So there's multiple ways you can solve these problems. I'm going to start you out the route just to understand what is happening here. So in example 1, you have to simplify the square root of 80. What you're going to want to do is, and eventually you'll find your own shortcuts, but you're going to want to prime factorize this. So when you prime factorize 80, 2 times 2 times 2 times 2 times 5, that would give you the square root of 80. Again, square root, you need a pair to move it out. The reason why you need a pair is because that would be really 2 times 2 giving us 4, like up here, which would give us 2. So I can move a 2 out. That would be essentially the square root of 4. Again, essentially the square root of 4, so I can move a 2 out. Now, there's only one 5, so that stays in your radical. And then you go ahead and multiply it out, and you would have 4 root 5 as your answer in simplest form. And in example 2, you have negative 5 times root 12. And again, if you need it in simplest mathematical form here, negative 5 inside my root, I'm going to prime factorize 12. I need a pair to move something out. So I have negative 5 times 2. Again, that's like the square root of 4. Inside your root, you have 3. So we have negative 10 root 3. In example 3, you have 6 root 81. Well, we know the square root of 81. It is a perfect square. That is 9. So this is essentially saying 6 times 9, giving you 54. You could break the square root of 81 into 2 9s. And notice, that's not even in prime factorization. But I could move a 9 out. Or you could look at it this way. The 9s could break down into 3s. So I could move a 3 out. I could move a 3 out. 3 times 3 would give you 9. Example 4, multiplication is commutative, so it doesn't matter how you multiply here. What I normally do is I take my terms on the outside of the radical and I multiply those together. So 2 times 3, and then I'd have times root 10 times root 20. These get multiplied together. We know that when multiplied together, you get the root of 200. So I think it's actually easiest to go ahead and break everything down right away. So what I do is I take the 10 here and I prime factorize 10 right away. So I'd have a 2 and a 5. I'd prime factorize 20. I'd have a 2, and a 5. It's easier to, I guess, start with those smaller numbers than to take the larger number there. But if you multiplied it all together, you'd get the root of 200. So again, looking for a pair here, we have 6 on the outside root. 2 would move out, a 5 would move out, so I'm going to move a 2 out. I'm going to move a 5 out because I have pairs, and again, it doesn't matter how I'd write it because it's commutative there. But we could move a 2 and a 5 out, which would leave you with the root of 2 left. Multiply those terms, you have 5 times 6 is 30, 30 times 2 is 60, root 2. Down in 5, they try to throw you a little bit of a curve. All they're doing is adding some variables in there. Follow the same process. You need 2 to move something out. So again, prime factorize number 5. I'm going to pause the video and you go ahead, prime factorize, and then we'll pick up from there. Here it is, prime factorize. Group your groups of 2's. I've moved what I can. Do my computation. I'd have 4x root 7y. Again, let's go ahead, pause that video, and work through example 6 and check back in. When multiplied together, I would get root 12 x to the 5th. That's what it would look like prime factorized. Groups of 2 there. I'm going to move a 2 out, and I get to move 2 x's out, so x squared. Inside my radical, I would have 3x. Down in question 7, this is where we're going to what's called as rationalize the denominator. Basically, when you rationalize the denominator, you have to get the root out of the denominator. We don't want a root in our denominator, so we need to eliminate our denominator, our radical in the denominator. So some simplifying happens here. What you need to think about is, how can I get the square root of 2 to a perfect square? Well, the easiest method, but not always the quickest method, is to multiply by the radical itself. So square root 2, square root 2. I'm going to multiply it. I have 4 root 12 on top when I multiply those, and root 2 times root 2 is root 4. So you can see that I have made a perfect square there. So I can get rid of the radical in the denominator. Next, I could go ahead and prime factorize, and I would have 4 root 12 is 2, 2, and a 3. All over the square root of 4 is 2. Now, I can go ahead and simplify on this problem right now. I have a 4 and a 2. If I simplify, right there, this is a 2, this is now a 1. I have a group of 2, so I can move a 2 out. So essentially on the top, I have 2 times 2, root 3, all over 1. And then I do my computation, I'd have 4 root 3, and this would be simplified. I got rid of that denominator. Example 8 is the one that I'm referring to, that yes, you could multiply by the root of 12. When you do that, you'd get 144, and the square root of 144 is 12. You might find it quicker, less reducing, if you go ahead and find another term. So not always do you need to multiply by what's in the radical. For instance, if I multiplied by the root of 3, on top here I would have 3, and I'd have root 8 times root 3, which is root 24, all over denominator 2 root. When I multiply that together, 12 and 3, I get 36. And you can notice here that the square root of 36 is 6. So instead of using the root of 12 to get 12, it's sometimes easiest if you can find something that would be a perfect square. So I multiplied by the root of 3. Carry this out here. You have 3 root inside my parentheses here. I have 2 times 2 times 2, giving me 8 times 3, all over 2, and we know that the square root of 36 is 6. So here's what my problem would look like so far. Again, you could go ahead and reduce right away within this problem. I have a 3 here. That would become a 1. I would have a 6. This would become a 2 when I do my reducing. I have a pair of 2's that I can move out. So essentially I have 1 times 2. This would give me 2. Root, inside my root there, I have 2 times 3, which is 6. All over 2 times 2 is 4. And again, you can see that I can reduce right away in this problem. When I reduce, I would have this become a 1 and this become a 2. So I'd have root 6 all over 2. 9, just to get you started, I can see that I can reduce right away. I have a 2 and a 4. I'll reduce that. This is a 1 and this is a 2. So I have root 3x to the 4th all over 2 root 6x. So again, what you'll need to do here is determine what you need to multiply to get rid of that radical. You need to rationalize that denominator. In this case, I'm going to go ahead and multiply by root 6x to get rid of that denominator. Do your computation quick. There's where we'd wind up. Following my prime factorization, I group my numbers here. I can move a 3 out, an x out, an x out. So basically I would have 3x squared root 2x. As my denominator, you can see that I moved out my 6x. So 2 times 6x would be 12x. And then I could go ahead and simplify. This would be a 1. This would become a 4. I have 2 x's on the top, so I can get rid of an x on the top, get rid of an x on the bottom. I would have x root 2x all over 4. Example 10, why don't you go ahead and give it a shot quick. Rationalize that denominator and we'll check back in. Following rationalizing my denominator, this is what I'd come up with. So I'd move my 5m out all over, rationalize this guy right up here. Numerically, that's what it would look like rationalized, and then I would obviously have 4m's. So determine what you can move out. I can group 2, an m, and an m. So on the top I have 2m squared root 5 all over 5m. And then you can identify that I can reduce an m out of each. So I have an m squared, I'll lose an m there, and I'll lose an m off the bottom. And my answer is 2m root 5 all over 5. This will conclude lesson 59.